1990, Japan built an engine so fast that American manufacturers lobbied to have it banned before it ever touched US soil. In 1994, Nissan created a motor so advanced that the EPA called it a threat to domestic competition and buried it in paperwork for 25 years. And in 1992, Honda engineered something so illegal in America that owning one could get your car crushed at the border. These 10 engines represent the greatest achievements in Japanese automotive history, and every single one was kept out of American hands by politics, fear, or corporate greed. Engine number 10, Mazda 20B, the 3-rotor that never crossed the Pacific. Start with the engine nobody talks about because Mazda made sure of it. The Mazda 20B, 3 rotors, sequential twin turbos, and a power output that made every American piston engine look like it was trying too hard. Most people know the RX-7's twin-rotor 13B. That engine was already a mechanical nightmare by conventional standards, spinning instead of pumping. No pistons, no traditional combustion cycle. Engineers at Ford and GM called it a gimmick. Then Mazda added a 3rd rotor and turbochargers, and suddenly nobody was laughing. The 20B made 280 horsepower at the crank from the factory. That number should sound familiar. It was the exact limit of Japan's gentleman's agreement, a voluntary horsepower cap that Japanese manufacturers imposed on themselves in 1988 to avoid government regulation. Every manufacturer reported 276 to 280 horsepower, every single one, regardless of what their engines actually made. Independent dyno tests on the 20B told a different story. Real-world output was closer to 320 horsepower stock, with torque figures that didn't belong in a car that weighed under 2,800 pounds. Mazda offered the 20B in the Yunos Cosmo, a luxury grand tourer sold exclusively in Japan. While Americans were still using paper maps, Mazda was building a twin-turbo 3-rotor GT car with satellite navigation. So why didn't it come to America? The EPA's emissions standards in the early 1990s were specifically structured in ways that rotary engines struggled to meet, not because the technology wasn't there, but because the testing methodology was built around piston engine characteristics. The 20B would have needed significant re-engineering to pass, and Mazda made the business decision not to bother. The result, one of the greatest Japanese engines ever built, never turned a wheel on American soil, legally. Today, a 20B swap is the holy grail of the rotary community. Finding a complete running engine costs north of $15,000, and that's before you factor in the custom fabrication required to fit one into anything that wasn't a Cosmo. Mazda didn't just build an engine, they built a legend by keeping it secret. Engine number 9, Nissan VH45, the V8 that embarrassed American muscle. In 1989, Nissan did something that should have been impossible. They built a Japanese V8 that outperformed American V8s that had 40 years of development behind them, and then they barely told anyone about it. The VH45 was a 4.5-liter dual overhead cam V8 developed for the Infiniti Q45 and the Nissan 300ZX Z32. 32 valves, aluminum block and heads, a 8,000 revolutions per minute redline in an era when American V8s were running out of breath at 5,500. Official output was 278 horsepower for the Q45 version and 300 horsepower for the Z32 twin-turbo variant. Both numbers were lies in the same direction, underreported to comply with the gentleman's agreement. Dyno testing showed the twin-turbo Z32 version producing closer to 365 horsepower stock, with torque delivery so smooth it felt like cheating. Here's what made American manufacturers nervous. The VH45 and the 300ZX put up quarter-mile times of 13.1 seconds from the factory, matching the Corvette ZR1 that cost nearly twice as much. Road and Track tested both cars in 1990 and printed the results. Ford and GM executives were not pleased. The lobbying that followed wasn't subtle. American manufacturers pushed hard for import tariffs and emission standards that would specifically disadvantage Japanese performance cars. They framed it as environmental concern. What it actually was fear. Nissan eventually discontinued the VH45 in the late 1990s. The engine that should have started a Japanese V8 revolution quietly disappeared, replaced by smaller, more emissions-friendly units. The 300ZX was discontinued for the US market entirely in 1996. Car enthusiasts who knew what they were looking at spent years trying to import Z32s with the full-fat engine configuration. Many succeeded and promptly discovered an engine that, with basic modifications, pushed past 500 horsepower without breaking a sweat. Nissan built one of the finest V8 engines in automotive history and let politics bury it. That's not a footnote, that's a crime. Engine number 8, Toyota 1UZ, the Lexus V8 Detroit tried to stop. When Toyota launched the Lexus LS 400 in 1989, they didn't just enter the luxury car market, they detonated it. The 1UZ was a 4.0-liter all-aluminum V8 producing 250 horsepower, numbers that don't sound dramatic until you understand the context. This engine was quieter than a Mercedes S-Class, smoother than a BMW 7 Series, and more reliable than both combined. It achieved these things while being lighter than comparable American and European V8s by over 100 pounds. Consumer Reports tested the LS 400 against every luxury competitor in 1990 and declared it the best car in the world. Detroit panicked. Chrysler chairman Lee Iacocca allegedly called the LS 400 the most dangerous car ever built, not because it was fast, but because it proved Japanese engineering had surpassed American engineering in the segment Detroit considered untouchable. The lobbying effort that followed was extraordinary. American manufacturers pushed for increased tariffs on Japanese luxury vehicles, framing it as trade policy while privately admitting it was survival instinct. The 1992 voluntary export restraints negotiated between the US and Japan specifically targeted the price points where Lexus competed. What makes the 1UZ legendary isn't just what it did in the LS 400, it's what it did everywhere else. The engine found its way into the Toyota Soarer, the Celsior, and eventually became one of the most popular swap engines in the world because it was virtually indestructible, made excellent power with simple modifications, and cost almost nothing used. Today, a used 1UZ with 150,000 miles is considered broken in, not worn out. Toyota built this engine to last 300,000 miles without significant work. American manufacturers were building engines that needed rebuilding at 100,000. Detroit didn't just face competition from the 1UZ, they faced an argument they couldn't win. Engine number 7, Honda F20C 9,000 revolutions per minute was just the beginning. Most engines run out of ideas around 6,500 revolutions per minute. The Honda F20C was just getting started. The F20C was a 2.0-liter naturally aspirated 4-cylinder that powered the Honda S2000 from 1999 to 2003. It produced 240 horsepower from 2 liters with no turbocharger, no supercharger, no forced induction of any kind. That's 120 horsepower per liter, a specific output figure that matched Ferrari's contemporary V8 engines. The red line was 9,000 revolutions per minute in a street car. With a warranty, VTEC engagement at 6,000 revolutions per minute transformed the engine's character completely, like 2 different engines sharing the same block. Below 6,000, it was smooth and manageable. Above 6,000, it became something that didn't belong on public roads. So why is it on this list? Because the F20C that Americans received was not the F20C that Honda originally built. The Japanese domestic market version of the S2000 produced 247 horsepower. The American version was detuned to 237, a difference that sounds small until you understand it was achieved by retarding ignition timing and recalibrating the ECU specifically to meet EPA requirements and liability concerns. Honda's engineers didn't want to detune it, their lawyers insisted. Furthermore, Honda had developed an F20C variant with individual throttle bodies that produced an estimated 270 horsepower naturally aspirated, an engine that could embarrass turbocharged competition, revved to 9,000 revolutions per minute, and do it all on regular gasoline was considered too extreme for American consumers. Honda built something extraordinary and was told to make it ordinary. They compromised, just enough to get the car through the door, not enough to kill its soul entirely. The F20C remains one of the greatest naturally aspirated engines ever conceived. What America got was a slightly lobotomized version of it. Engine number 6, Subaru EJ207, the engine America got a watered-down version of. Subaru sold Americans the WRX STI and called it the full experience. That was not entirely true. The EJ207 is the engine that powered the Japanese domestic market Impreza WRX STI from 1994 onward. A 2.0-liter turbocharged flat 4 with an inverted V-mount intercooler, individual throttle bodies on some variants, and a factory output of 280 horsepower, that number again with real-world output closer to 320. Americans Americans received the EJ257, a 2.5-liter version, larger displacement, same basic architecture. On paper, it sounds like an upgrade. In practice, it was a compromise forced by emissions regulations and the reality that the 2.0-liter EJ207 would have required significant recertification to meet US standards. The EJ207 revved higher, breathed better, and in the hands of Subaru's World Rally Championship team, produced over 300 horsepower in road-legal trim and 400 plus in full competition specification. It won 4 consecutive WRC manufacturers' championships. It was one of the most developed turbocharged 4-cylinders in motorsport history. What made American enthusiasts furious wasn't just the engine swap, it was discovering, through gray market imports and JDM spec sheets, exactly what they'd been given instead. The EJ257 was softer, torquier at lower RPM, and tuned for a market that valued drivability over edge. Subaru's American engineers called it a maturation of the platform. Subaru gave America a great car, they just kept the greatest version for themselves. Engine number 5, Mitsubishi 4 G63T, the Evolution Engine Insurance Company's declared war on. There are turbocharged engines, and then there is the 4 G63T, an engine so tunable, so over-engineered from the factory, that it became the foundation of an entire performance culture and the target of an industry-wide insurance campaign to make it disappear. Mitsubishi built the 4 G63T for the Lancer Evolution starting in 1992. 2 liters, turbocharged, all-wheel drive, and a factory output of, you know the number, 280 horsepower. What made the 4 G63T different wasn't the headline figure, it was the bottom end. Mitsubishi built the 4 G63T's internals to handle significantly more power than they ever reported. The forged crankshaft, forged connecting rods, and iron block weren't necessary for 280 horsepower, they were necessary for 500 horsepower, which is where these engines comfortably lived with basic bolt-on modifications. The factory turbo could support 400 horsepower before needing replacement. The block itself has been proven reliable past 600 horsepower in built form. Mitsubishi built a streetcar engine with race car internals and sold it for the price of a family sedan. When the Evolution arrived in America in 2003, insurance companies did the math immediately. A car capable of genuine 500 horsepower potential in the hands of anyone with a laptop and a weekend was not something actuaries were comfortable with. State Farm and Allstate flagged the Evolution as a high-risk vehicle before the first one was delivered to a dealer. Premiums for drivers under 25 were extraordinary, in some states exceeding $4,000 annually for basic coverage. Mitsubishi dealers reported customers walking out when they got their first insurance quote. The car's price was manageable, the cost of owning it legally was not. Mitsubishi sold the Evolution in America through 2015, but the insurance industry's sustained pressure on young buyers, the exact demographic the car was designed for, contributed to its commercial struggles. The Evolution was discontinued, and with it went the 4 G63T in its final, most developed form. An engine that could run 10-second quarter miles on a tune file costing less than a dinner out was considered too dangerous to insure, so they priced the danger out of reach instead. Engine number 4, Mazda 13 BREW, the rotary the EPA spent a decade trying to kill. The 13 BREW was the twin turbocharged rotary engine that powered the RX-7 FD from 1992 to 2002. No pistons, no valves, no camshaft, just 2 spinning triangular rotors creating combustion through pure geometry, with sequential turbochargers stacked to deliver power across the entire RPM range rather than in a single violent surge. Factory output was 255 horsepower in the Japanese market. The American version received 252, a reduction that sounds trivial but was achieved through ECU mapping changes specifically designed to reduce peak combustion temperatures and thus lower emissions readings during EPA testing. Mazda's engineers didn't want to detune it, the testing cycle left them no choice. The rotary engine's emissions profile is different from a piston engine's, not necessarily worse, but different in ways the existing testing methodology wasn't designed to measure fairly. Hydrocarbons come out differently from a rotary. The test cycles were calibrated for piston combustion. The rotary was being measured by rules that didn't fit its architecture. Mazda fought this for years. They submitted engineering data, requested methodology reviews, argued their case through multiple regulatory cycles. The EPA's response was effectively meet the standard or don't sell the car. The standard was designed for a different type of engine. By 1995, Mazda had pulled the RX-7 from the American market entirely. Not because the car wasn't selling, it was but to an extremely loyal audience because the regulatory cost of keeping it compliant was becoming unsustainable. The 13B that Americans missed out on after 1995 was Mazda's most developed version, higher flowing turbos, revised porting, and an output closer to 280 horsepower in late production form. It weighed almost nothing. In a car that tipped the scales at 2,800 pounds, it produced a power-to-weight ratio that contemporary sports cars couldn't touch. Mazda built an engine that reimagined what an engine could be. Engine number 3, Toyota 2JZ, the engine that broke the gentleman's agreement wide open. Here's where the story shifts. Because the 2JZ wasn't banned, it wasn't blocked, it wasn't detuned into irrelevance. It came to America, and it still broke everything. Toyota's 2JZ was a 3.0-liter inline-six with sequential twin turbos, an iron block so overbuilt it became the stuff of engineering legend, and a factory output reported at 276 horsepower right at the gentleman's agreement limit. Every other manufacturer was stretching the truth to hit 280. Toyota's engineers were embarrassed by how much they were understating it. Independent dyno tests consistently showed the 2JZ producing 320 to 330 horsepower at the crank in stock form. The engine's real capability only became clear when tuners started pushing it. 400 horsepower required almost no internal modifications, just a bigger turbo and a tune. 600 horsepower was achievable on the stock block. Stock internals, stock everything except the forced induction system. The iron block is why Toyota built the 2JZ with cylinder walls so thick and main bearing surfaces so substantial that the engine could handle pressures it was never supposed to see. Whether this was intentional over-engineering or conservative design philosophy for long-term reliability, the result was the same. An engine that laughed at power levels that would destroy anything American manufacturers were building at the time. Engine number 2, Honda C30A, the Ferrari killer America almost never got. In 1990, Honda built a mid-engine supercar with a naturally aspirated V6 that humiliated Ferrari's contemporary offerings on road courses and cost less than half the price. Then the American government and domestic manufacturers made sure as few people as possible ever knew about it. The C30A was a 3.0-liter DOHC V6 developed specifically for the NSX, VTEC on both intake and exhaust camshafts. Titanium connecting rods, a first for any production car engine, a 8,000 revolutions per minute redline with a throttle response so immediate that Ayrton Senna, who consulted on the NSX's development, reportedly said it felt like a Formula car. Factory output was 270 horsepower in the Japanese market and 252 horsepower for America. The reduction achieved through a revised exhaust system and recalibrated fuel mapping to meet California emission standards. Honda's engineers considered this a personal insult. They had built one of the most sophisticated, naturally aspirated engines on the planet and were being asked to turn it down. Ferrari noticed. Enzo Ferrari was reportedly furious about the NSX, understanding immediately that Honda had demonstrated something dangerous, that Japanese engineering could match and exceed Italian passion on a race circuit. The F40, Ferrari's flagship in 1990, was faster in a straight line. On a road course, the NSX was the better driver's car. The American automotive lobby's response to the NSX was to push for interpretation of emissions regulations in ways that specifically disadvantaged Honda's engine architecture. CARB regulations in California required modifications that cost Honda significant development resources and forced the power reduction that distinguished the US market car. What Americans drove was still extraordinary, a 252 horsepower mid-engine sports car that handled with supernatural precision. But the full C30A, unrestricted and breathing properly, was something else entirely, something Ferrari had nightmares about. Honda eventually replaced the C30A with the C32A, a 3.2-liter version producing 290 horsepower for the American market. Better than the detuned C30A, still not the engine Honda's engineers originally intended you to have. The Ferrari killer came to America with its teeth filed down, and it was still terrifying. Engine number 1, Nissan RB26, the engine that was too fast to be legal. Everything on this list has been building to this. The engine that didn't just win races, it changed what people believed was physically possible in a production car. The Nissan RB26, twin turbo, inline 6, 2.6 liters, and an official output of 276 horsepower that fooled absolutely nobody. Nissan developed the RB26 for one purpose: to win the Group A Touring Car Championship with the GTR. The rules required a production version available to the public, so Nissan built the R32 GTR in 1989 and told the world it made 276 horsepower because the gentleman's agreement demanded it. What it actually made was somewhere between 320 and 330 horsepower stock. The RB26's iron block and closed-deck architecture could handle boost pressures that destroyed other engines. The factory turbos were already large for the era. The head flowed air with an efficiency that Nissan's engineers had refined through multiple motorsport programs. Every component in the RB26 was built with the understanding that it would be modified, because Nissan's engineers knew exactly who was buying a GTR and exactly what they were going to do with it. 400 horsepower on the stock engine was weekend work. 600 horsepower required an upgraded turbo kit. 1000 horsepower was achievable and was achieved repeatedly by teams running RB26s in time attack competitions on a block that left the factory in 1989. The GTR terrorized Australian touring car racing so completely that it was banned from competition after 3 years. The car had won every race it entered. Not most races, every race. Officials rewrote the rulebook specifically to exclude it. America didn't get the GTR until 2008, 19 years after Japan released it. The RB26 was never officially sold here. Owning one required navigating gray market import regulations, and getting one wrong meant customs could and would crush the car at the port. People did it anyway, because no engine in this list, no engine in this era, represented what the RB26 represented.